Okay, next example we have here, of course, involves having the square root. So when it comes to determining the domain here, of course, what you have to be careful about is those values that would, cause you to have the square root of a negative. So your domain would be as long as you keep x being a value of 9 or less. Like for instance, of course, 9 would give you exactly 0, which is fine. And then if you went anything that's less, say an 8, of course 9 minus 8 is 1. I mean, even if you went into your negative values, say negative 2, then you would have 9 minus negative 2, which is positive 11. So you are going to have some restrictions here with your domain as well. Okay, first derivative. Now, doing your derivative on this one, of course, you would want to rewrite this as 9 minus x to the 1/2 power. But after doing that, you'll have to use your product rule, because this would be your first function and this would be your second function. But what you will end up with for your first derivative, okay, so that would be what you should get for your first derivative. All right, so finding our critical numbers, taking your numerator, finding what value causes that to equal 0 would be a positive 6. Taking your denominator, finding the value that causes it to be equal to 0 would be positive 9. Now, on your sign graph for this one, though, because your domain has to be anything that's less than 9, like when you're doing your sign graph, like this end has to stop at 9. Like you wouldn't have an arrow, meaning that you're including all those values that are larger than 9, but it would continue to include all the values less than 9. So of course 9 is this last number that we have here, but there's no need to test anything on this side of 9 because of what our domain is. So the only number that you end up actually marking off is going to be the 6. Okay, so test numbers, I'm going to use 0 and 7. This is going to be a positive section. This is going to be a negative section. Again, you're plugging those values, remember, into your first derivative. So this section's increasing, this section's decreasing. So increasing would be negative infinity to 6, and decreasing would be from 6 to 9. Now, at 6, you would have a maximum value there because you are increasing and then decreasing. Now, since you don't have a section on this side of 9, then 9 is not going to be the location of a max or a min. So substituting 6 into the original function, you will end up with 6 square root 3. So this will be your maximum value, okay? Now when you go to plot the point, like 6 square root 3 is approximately, like 10.4. So like that would be what you need to think of as your value when we go to graph it. Okay, second derivative. Again, you're going to have to use quotient rule on this one for the second derivative. And this will be what you will end up with. Okay. All right, so finding these values that will cause the numerator to equal 0. And then what causes your denominator to equal 0. Okay. Now, just like a while ago with your sign graph, this end's going to stop at 9. Okay, so that would be this value. This being x equal 12, that's not even in your domain. So when it comes to testing for your second derivative, you just have this one large interval that's either going to, all of it's either going to be concave up or it's all going to be concave down. So just pick you one number, that would be there. So I'm going to use 0. If you're going to substitute that in, then this will actually all be concave down is what we're going to have. So concave down would be negative infinity to 9. Now, you're not going to have any points of inflection because you would have to have, remember, a change in concavity in order to have points of inflection, okay? Now, intercepts, so x-intercept, of course, that's going to be the values that are going to cause your function to be equal to 0. So actually, if you just find out what makes this factor equal 0, what makes this factor equal 0, so that would just be x equals 0 and 9 minus x equals 0. So this would be the point 0, 0, and this would be the point 9, 0. And then y-intercept, of course, that would obviously end up being 0, 0. Of course, you find a y-intercept, remember, by substituting 0 in for x. So you're going to get 0. Okay, so graphing this one. Okay, so plotting the points that we have here. Of course, we had 0, 0. We had 9, 0. And we had 6. And then approximately 10.4. Okay. All right, so there's our 3 points that we have found. Now, if you remember, your graph starts off increasing. See, increasing is negative infinity to 6. So you have to start off increasing, and then you increase until you get to this maximum value, and then you decrease. But your graph, remember, stops at 9 because that's where your domain stops. So like this portion of it here, and I don't have I've run out of paper, but this portion would just come on down and just keep coming down. But it increases and then it decreases, and if you remember, the whole thing is supposed to be concave down, which is what we have.